Assalamualaikum and hello everyone. Welcome to a new video for a new chapter, chapter 1 reaction kinetic, which is the first chapter of semester 2, chemistry SK025. Okay, so in this video, what we're going to learn is for subtopic 1.1 reaction rate, and specifically in this video, what we're going to learn is to define the reaction rate itself, explain the graph of concentration against time in relation to reaction rate, write differential rate equation, as well as determine the reaction rate based on a differential equation. So what is actually reaction rate? Reaction rate is the change in concentration of reactant or product with change in time. So this is the formula where rate is equal to change in concentration, or the other name for concentration is molarity. So concentration here, the unit will be capital M, or it is mole per liter, and then divide by time. Time, it could be second, it could be minute, it could be hour, it could be day, it could be even year or month itself. Okay, so how about the unit? So the unit itself, so it's either for the concentration, or you want to write mole per liter or capital M, it's fine, and divide by time. So for example here, mole per liter per second, or you're going to write down a capital M per second, it could be M per minute, M per hour, or based on the question, if the time given to you is day, so you're going to write down the reaction rate is molar per day lah. Okay, so that is the definition of reaction rate and the unit. Okay, so consider a reaction where we have our reactant and we have our product. Okay, so here what we have here is actually a graph of concentration against time. Okay, so for example, here is A is our reactant. So at the start of the experiment, I'm just going to give any value. For example, here I'm just going to write down 1.0. Okay, so as the time proceeds, our A will change to B. So what would happen is that as our reactant combine or form product itself, the concentration of A will decrease. For example, here the concentration initially is 1.0. So for example, here I'm just going to write down the value, the concentration will decrease to 0.7. Okay, why the concentration decrease? Because our A has changed to B, or from our product itself. So here, as the reaction proceeds or time increases, the concentration of reactant decrease. Meanwhile, for our product or our B itself, okay, when T is equal to 0, because at the start of the experiment, the product is not formed yet. So what will happen is that at T equal to 0, the concentration will be 0. But as the time proceeds, as A has changed to B, as our reactant has formed product, so the concentration of product will increase. So here I'm just going to write down increase. Okay. So for example, here 0, then concentration decrease to 1.0 as the proceed. Okay, so what happened here? If we're going to write down the rate itself, okay, rate is equal to negative dA over dt. Okay, this is change in concentration or divided by change of time itself. Okay, so why is the negative sign here? Negative signs here, it does not mean that the concentration is negative value, it's not. Negative need to show that the concentration decrease. As you can see here, the concentration is decreasing. Okay, because for the concentration, time, length, this is something that there is no negative value kan. Contohnya there is no negative 1 second, there's none kan. You can see 1 second. There's no negative value. The same goes for our concentration ni lah. Concentration will always be a positive value. The negative ni just to show that concentration decrease. Okay, so negative dA over dt and equal to the rate is positive dB dt. So positive ni, it shows that the concentration is increasing. So you have to include the positive sign. Okay, so dB over dt. So that is only the introduction of what is rate and how to write the rate equation. Okay, so next what we're going to write down is the differential rate equation. So for the differential rate equation, it is actually the relationship between the rate of disappearance of the reactant and the rate of appearance of product. Okay, so it is the same as this one. Okay, tapi we just going to apply that knowledge lagi. Kita akan tengok pada certain equation. How to write down the differential rate equation based on a given equation. So for example here, we have our A and B is our reactant, C and D is our product. Okay, so how we're going to write down the differential rate equation? First, we're going to write down rate is equal to, first, our reactant ni is actually, dA over dt. So we have to include the square bracket. Square bracket ni means that it is our concentration. Over dt. So how about negative 1 over A ni? Negative ni, so for the reactant, I'm just going to write down here, reactant, you have to include negative sign in front of it, because why? Because for the reactant itself, the concentration will decrease with time, but if the product, what will happen is that the concentration will increase over time. So we're going to write down positive sign. But then from here, as we can see, so negative 1 over A. So 1 over A ni apa pula? 1 over A ni is actually our stoichiometry. For example, for here, if we have 2, so here we have to write down 1 over 2. The stoichiometry given in the equation. Because once you have balanced the equation, usually you can see the value lah. For example, here 2, 1, 3, 1. Okay? So we have to include the stoichiometry as well. So here negative, here is actually for our A, for reactant A, equal to the reactant of B kita. Pun the same juga as it is a reactant, it must have a negative sign in front of it. So once we have write down the A and B for our reactant, we're going to write down our product. So product lah, remember product is positive because as time proceeds, the concentration of product increase. So here, what we have, positive 1 over C, the small c, all the small letters again is the stoichiometry lah. Stoichiometry tu number in front of the equation. Equal to our product as well, another one of our product, 1 over D, change in concentration of D divided by change in time. So yang ini pening dah macam mana nak tulis. So let's look based on specific equation. So first we have is actually a formation of ammonia. So how we're going to write it down? First, before anything, we have to include our rate. So I'm just going to write down rate is equal to, so again, remember reactant must be a negative sign. So here is negative. So here I'm just going to write down negative, but here we have to write down 1 kan, 1 over something. But this equation is 1 over 1. So 1 over 1, do we have to write it down? There's no need. If you want to write down just straight away, d and 2 over dt. And then kita akan straightforward sajalah. So this is the first reactant. The second one is still our reactant. Reactant kita, so it must be a negative. So I'm going to write down negative. But in this case, our stoichiometry is 3. So we have to include. So we're not going to write down just 3. Remember, there must be 1 over our stoichiometry. So here, 1 over 3. So this is change in H2 over dt. And then, last but not least, our NH3. NH3 is our product. So for product itself, it is a positive value. So positive sign, we have to include it. Walaupun it is understood if there is no sign, it means that it is positive lah kan. But then for the differential rate equation, explicitly write down it is positively signed. So here positive. Here is 2. So we have to write down kan 2 di NH3. We have to include 1 over 2. So here 1 over 2 d NH3 over dt. So this is the equation. So again, for this equation, first you have to include our rate itself. Remember, for the reactant must be a negative sign. For our product must be a positive sign. For if the stoichiometry in front of the equation is 1, it's fine if you don't want to write it down 1 over 1. But then make sure the positive sign, our product too must have positive here lah, in front of the fraction itself. So question B, C, D, I believe you could try yourself. Okay, and then for the equation, for the differential equation, sebenarnya it is actually applicable for all. Okay, regardless if it is solid ke, applicable for all state. For all solid, liquid, gas equals. Okay, so for the example here, mostly I've mentioned it. Gas, if we have solid ke, if we have liquid, we're going to include all of it. Okay, for next page, we're going to do, based upon differential equation, we're going to do calculation as well. Okay, so now let's look for question E. So here is the information, rate of formation of I2 is 1.8 exponent negative 6 molar per second. But then the first question they ask for the differential equation, so we have to write rate equal to the negative and the positive sign. It's important for you to write down the rate as well. Rate is equal to. Okay, and then based on this equation itself, we have our reactant and product, reactant negative, and then here, because we have 2, so it will be negative 1 over 2 dHI over dt. So this is for our reactant. Okay, and then we have to equal to the rest of our species, which is our product. It must be a positively sign. So you could write 1 over 1, or only positive one, it's fine. So dH2 over dt is equal to, okay, then we have another one, which is I2. So we're going to write down positive di2 over dt. So that is our differential rate equation. So now is the new type of question. They ask you the rate of disappearance. This is the question. Disappearance, it means that it is the concentration decrease lah. So it must be a negative sign. So dHI over dt is equal to our unknown lah. We do not know. This is the question that we want. Okay, so I'm just going to write down it's Sx only. Okay, so rate of disappearance. Okay, right now it's negatively signed. We don't have to include any ratio. We know that disappearance memang negative. Okay, but then the information given is rate of formation. Formation is forming product, so it will be positive. So positive, but then the rate kan. So positive di2 over dt is equal to 1.8 exponent negative 6 molar per second. Okay, so this is the information that we have. Okay, yang ni pun don't have to include ratio. Only yang positive or negatively sign sahaja. Okay, so right now what we're going to do, how to get the answer, we're going to compare this. Okay, compare from which equation? From a differential rate equation. So here we have yang dHI over dt ni equal to di2 over dt. For comparison, we have to include from our original differential rate equation. Okay, but then rate of disappearance is only this one. We don't want the 1 over 2 too. We do not want it. So how I'm going to do it? So I'm just going to change the color for it just to make it more clear to you. Okay, so what we want is the green one. Okay, from the ini. Okay, ni yang kita nak. So how we're going to do it? di2 over dt ni is exactly as the information given. So what we're going to do now is actually 1 over 2 ni. Okay, we're going to move it to the other side, so it will be multiply. Okay, so here I'm just going to multiply by 2. So from here, so we have this is the question that we want, dHI over dt. Okay, next is what I'm going to do is I'm going to do the calculation straightforward sahaja. So the answer is 3.6 exponent negative 6. But how about the unit? Because from the information, this is molar per second. So this one pun unit pun molar per second. Okay, so this is actually from the information dan question. There's no need for the ratio lah. Sebab tu lah for the information tu tak ada ratio pun, regardless of from the differential rate equation. Bila kita compare, when we're comparing it, then we're going to include the ratio from the equation itself. Okay, so but then, even though the rate of disappearance, why the answer is positive? Because for the concentration, the same as time, it will always be a positive value. Negative ni just to show that the concentration is decreasing. It does not mean that the concentration is negative. Okay, so another way of seeing it, lagi straightforward sahaja. Okay, kalau kita nampak ratio dia 1 to 2. So, for example, I2 2 molar, HI2 4 molar lah. So, kat sini 1.8, HI akan jadi 3.6. So, straightforward pun boleh tengok juga. But then, this is the steps on how to answer the question itself. Okay, so now kita tengok pula untuk question F. Okay, so for question F, dia bagi rate of disappearance. Okay, first, dia minta differential rate equation. Okay, this one kalau kamu tulis sini je salah. Why? For differential rate equation, we have to include rate is equal to. Ini, the one that people always forgetting is actually the rate equal to. This is very correct lah. Question number 2, rate of formation of H2. So remember, from the question dengan information, don't have to include the ratio. So we're just going to write down formation is a positively sign. So positive dH2O over dt is equal to 0. That is our unknown. Okay, but then the information given, rate of disappearance is negative. So here dO2 over dt is equal to 0.323 molar per second. Okay, so from the information and question, there's not for ratio, but when we're comparing it, kita akan ambil from differential rate equation lah. So dH2O dt ni the one that we're going to find. So yang ni menjadikan on my left hand side is equal to dO2 over dt. So yang ini, I have changed it 1 over 2 to, I have moved it to the other side. So times 2. So what I have here is 0.23 times 2. So we get 0.46 molar per second. So this is the steps on how to answer the differential rate equation. Okay, so remember, kalau nak mula straightforward pun boleh. Tengok ratio dia straight sahaja pun boleh juga. And the constitution will always be a positive value, the rate. Okay, now for question G. Okay, so for question G itself, ni kata rate expression. What is rate expression? Rate expression tu is the same as our differential rate equation. So boleh include lah rate expression, differential rate equation is the same thing. So question 1 and 2 ni, so this is the answer for question 1. Ini mesti perlu explain apa-apa lah kan. Okay, next is question 2. Okay, rate of NO2 being formed. So it's positive signs. You don't have to include the ratio. So dNO2 over dt is equal to x, our unknown. But then the information rate of disappearance, it means that it is negative. So negative dNO over dt is the value given, 0.066 molar per second. Okay, so sekarang ni what we're going to do is actually do the comparison. So from the comparison, barulah kita akan ikut straight away from our differential rate equation. Remember, the one you're going to find out, I'm going to write down the left hand side lah. Okay, so right now I have written it down. So macam mana ni? Negative 1 over 2 ni. Okay, so remember, sebenarnya from this equation itself is actually 1 over 2 positive dNO over dt. Okay, so kalau nak tulis bracket pun lagi jelas untuk kamu boleh. Is equal to 1 over 2 negative dNO over dt. The negative and positive sign tu is actually for the rate. It's not for the ratio itself lah, ataupun the fraction itself. Okay, so macam mana kita nak buat ini? So remember 1 over 2 ni ke sini, so multiply by 2. Tapi kita tahu ni kita boleh cancel out. So sama sahajalah, dNO2 dt is equal to the same value, which is 0.066 molar per second. Okay, so for this question, remember that the negative tu, kalau kamu blur, negative tu is actually for the rate. It's not for the 1 over 2 ke apa. Okay, so kita tengok straight away pada sini pun kita boleh nampak it's the same ratio, so the answer will be the same. For the rest of question, I believe you could try it yourself.